We are on the page 11, section 7.1, something called GCF and factoring by grouping. We say in this class, we only learn one thing, how to solve a quadratic equation, right? Then last week, week 1, we did chapter 5, that's miscellaneous things, 2 by 2 we are learning, right? So we start to learn how to solve a quadratic equation. You don't know what that is yet, but start from here, we go back to learn something called GCF and factoring by grouping. We learned something with GCF, right? What does that mean? GCF means what? Greatest common factor. Okay, so let's review the concept first. The things we use, then how we use it, right? So for multiplication, 2 times 3 is what? 6. The result of multiplication, we call it what? A product, right? Result of addition, we call it sum. Result of subtraction, we call it what? Difference. And result of multiplication, we call it a product. And result of division, we call it what? A quotient, right? That's the term. Those are the terms we use. So we start to talk about more emphasis on multiplication. The result we call it product. Each one, the things cause the result to happen, the factors cause the result to happen, each one we call it factor, right? Those are factors of 6. How do we do that? Remember, we use the trees, then we break down things to each tiny part, the smallest unit, which is what? Primes, right? So, those are numbers. Now we start to do the variables. So you learned in the previous course, 152A, we multiply them, right? 2 terms times 2 terms. How do we do? We FOIL, right? Then the result is what? Trinomial. You combine like terms. So the result of the multiplication, we'll call it product. Then each individual thing, we call them what? A factor, right? So we do what? Something multiplies something is a product. And if this is something, each individual one is a linear, smallest unit, pretty much you can be, then we call them what? Prime polynomials, right? For each numbers, we call them prime numbers. Then for polynomials, we call them prime polynomials. How we are going to find the GCF? Okay, let's do the numbers first. Then we do polynomials thing. So GCF means what? Greatest common factor. Within all the factors, which one is the largest one? Like 36 and 90. Which number can go into both and it's the largest one, right? If we look at the 36, the factor would be what? 1, 2, 3, 4, 6, 9, 18, right? Then for 90, there are many. 1, 2, 3, now 4, 5, 6, 7, 8, 9, right? 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, and okay, 30 maybe, and many 45, things like that. Okay, so what's the common factor? You have many, right? 3, 6, 9, 80. Which one is the biggest one? Greatest common factor, that's 18. That would take forever. So we did this in 187 class. What do? We use the tree, right? So you break down 36 become what? Say 3, 12, and 3, 4, 2, 2. Or you can do, say, 6, 6, right? That would be 2, 3, 2, 3. So you circle your tree leaves. 2, 2, 3, 3. You end up same, right? So we will write it from smallest one to largest one. So your 36 would be what? 36 would be 2, 2, 3, 3. 2, 2, 3, 3. Right? Then let's take a look at 90. 90 would be what? Okay. 90 would be 9 and 10, 3, 3, 2, 5. You only circle the tree leaves, the smallest one. The in between we call tree trunks, just temporary to branch the trees, right? So you will write a 90. 90 would be what? 2, 3, 3, 5. So you lined up 2, right? 3, you lined up with 3 and 3 and 5, right? Then take a look. What do they have in common? 2, you break down to the smallest units. So 2, these two only belong to 36, not 90. So it's not common. So you do 3 and 3, right? Then what do? You multiply them together. 2, 3, 3 is what? 18. That would be your GCF. That's how we find the GCF, right? So you write each number as product of primes. So you write it to the smallest units, which are the building blocks for all the numbers by prime numbers. Then you find all the common one, right, by lining them up. Then last step you would do is GCF by multiplying all of them together. That's how we will do the GCF. Let's look at the second one, 55 and 21. So what's our 55? 55 would be what? 5 and 11. So you write 55 equals what? 5 and 11. 21 would be what? 3 and 7, right? This is example 2. Then 11, 21 is what? 3 and 7. 3, it cannot line up, so you write it at the back, right? So what's your GCF? Do they have anything in common? No, right? When they don't have anything in common, their GCF will be 1. Let's look at the example. For 3 numbers, you will do the same. Okay? For 18, that would be what? 2, 9, and 3, 3. So you write them out, right? So 18 is what? 2 times 3 times 3. Then 42 would be, say, 6, 7, right? 6 would be what? 2 and 3. So we do that. So you line them up. So 42 would be, let me change the other marker. 42 would be what? 2, 3, 7. 2 times 3 and 7. Right? And 84 would be, say, 4. If you cannot see it right away, just do the 2, even number. 42, 6, 7, 2, and 3. So it's 2, 2, 3, 7. So 84 would be what? 2, can I line up 2, right? And 3 and 7. So what's your GCF? GCF would be the thing belongs to all of them. 3 of them, then you have to do 3. So what's your GCF? That would be 6. Right? So that's how we do the numbers. And we break down the numbers to the smallest units. Okay? That's called what? Factoring. Break it down to the smallest units. Just like all the science, what do? We analyze it by breaking down to the smallest units. Like our bodies, we have eyes, we have hearts, different parts. So you break it down, then you analyze different parts, and to find a cure, then find a problem, then put it back together, right? So for factoring, what we do is we break down things by multiplying them together for each part. For numbers, break down to each part, that would be all the prime numbers. And what happens if for the variable, right now we just do the one term, right? So for the variable, same thing. If I have, for the first example, say I have x cubed, x seventh, x fifth. Right now, before we do all the breaking things down, we try to find a what? GCF, which is common to all of them, all the numbers. Then we use GCF to break things down later. Okay, so for these 3 so how many terms we have? 1 term, monomial, monomial, monomial. So we try to find out what's the GCF, which one can go into all of them. X cubed means what? X times X times X 3 times. 7 means what? 7 times. Fifth means what? 5 times, right? So you break down to each individual, then what do they have in common? 3 of them. So your GCF is what? X cubed, because X cubed can go into each one of them, right? So we try to find a GCF for each individual term. They are all monomial, right? So what's your GCF? We do it number with numbers. For 6, 10, and 8, that would be 2. We only use positive number because it can divide into all the negative number. In numbers by themselves, you find the GCF. Then for x's, x squared, x cubed, x, what do you think? GCF will be x, because x can go into all of them. So that would be your GCF. For the third one, what do you think your GCF will be? For A, so you compared same variable for the other A's. So what do you think? Q fifth, sixth. GCF would be the one can go into all of them. That would be a cube. Then how about B? B squared, B squared. That would be the B. So that would be your GCF. We are on the page 11 still. Okay, let's take a look. If we have more than one term, before we tried for monomial, different on the previous section is like this, this, and this, right? Which one, single variable, which one will go into all of them, right? Now let's take a look. If I have 6x plus 18, how many terms I have? 2, binomial. So 2 terms, what do we need to do? Something called factoring. So factoring means what? We are going to write the things, something multiply something, right? Each individual would be the prime. Then we multiply them together, like 2 times 3. Then we call it, each one is a factor into a product. So that's how we want to break down things first. In all your science field, like a medical field, we break down a person to different parts, like eyes, hearts, legs. Then each one has a special doctor to take care of it. So we break down things to each small part, and we analyze for each small part, then we find the solutions. And we put it together, multiply back. That's the scientific approach to solve problems. So we started to do with numbers to break things down, okay? To become what? Multiplying. So we call them factoring. So start from here. How many terms I have? 2, right? 2 terms, 6x and 18. So number with number, what do they have in common? For GCF, that's 6. So we take them out. And for the first term, you take 6 out, you have x. 18 become positive 3. Each one has a sign. Each term has a sign. So you put a sign in front of the number, in front of the term. Only for the first one, if it's positive, we don't have to write it. So this one, number you keep by its GCF, by itself. Then second one, so you have what? Something multiply something multiply something. Then we call it factoring. For the second one, if y5 and y7, what do we do? For 2 terms, 5/5, y5, y7. What's your GCF? y5, right? So for y5, then take out y5, you only have 1, because y5 times 1, you go back. Then sign minus, and y7, you take y5, take away 5 of them, so you have 2 of them left. So that's how we factor it, by factoring out GCF, by taking out the GCF. So we always take out the GCF first when we do the factoring. The third one, 9/5 plus 18a squared minus 3a. We write in standard form, usually from highest power to the lower power, right? That's called standard form for the polynomial. So all the number 9, 18, and 3. What's the common factor? GCF, it's 3. But if leading coefficient is negative, we put a negative out. Okay, that's the practice. So inside the parentheses, always what? Positive to begin with. So A5, A5, A2, and A, what's the common one? That's A. So what do we have? Take a negative 3, so 3, A4 left. Then second one, take a 3 out, it's a negative, right? That would be 6. A squared, take an A out, you have 1 left. 3A, take a 3A out, so you only have what? 1 positive. So how do you know you are doing right? You multiply back and to check if it's okay. For the fourth, 15p squared q fourth plus 20p q p third q fifth plus 5p q q cubed. Right? So 15, 20, and 5, your GCF is 5. Then how about the remaining p squared q fourth? Am I writing correctly? Right. P3, p third, and q fifth, p third, and q third. Right? Same variable you check. Which one? It's comma p squared. But 15 divided by 5 is 3. So for the first one, right? So, oops, we are checking all the variables for the p and q for the GCF first. So it's what? P squared and q, how many? Q thirds. What's left? Right? So what's left? For this one, p squared q fourth, take p squared q cube out. You only have q, 1 q left. Oops, what happened to the number? 15 divided by 5 is 3, so 3 cubed. For the second term, 20 take away 5, that would be 4. P cubed and take out p squared, so you have 1p left. Q fifth and q cubed, that would be q squared, right? Then for the third term, 5, I take out p cubed, take out p squared, so you have p left. Q cubed is 1, so out. So that will be your answer for this one we call factoring by GCF. You take GCF out, the remaining you put in next parenthesis. So 1 term, 3 terms. 1 times 3, 3 terms. Originally, you have 3 terms. So what are we doing? The things we are doing is called factoring by GCF. You take GCF out first. Look this situation, next one, right? It's separated by plus sign, multiplication plus something, multiplication. So in these two groups, what do they have in common? X plus 3. That's how you do factoring by GCF. That's your GCF. For the first group, what's left? 5. For the second group, y. But you have sign. So that's how you do. Or you can write what? X plus 3, 5 plus y. They are the same. 3 times 5, 5 times 3, they are the same. So sequence for multiplication, it's interchangeable. You can do that. For the next one, what do you think? What do they have in common in these two groups? That's the one, right? So you take them out. Then for the first group, what's left? 3m squared plus n, right? For the second group, if you take out, it means what? You have invisible one here. So you minus 1, put the parenthesis there. So it means what? Something multiplies something, it becomes what? A factored form. That's what we want. Factoring by what? Taking the GCF out. Now we are going to do factoring by grouping. You are on the page 12. Let's see, what do we mean by factoring by grouping? Okay, look at the example, first one. How many terms we have? 4 terms. So we can just split it to 2 groups. See what will happen? So for the first group, what do you have in common? X, right? Then what's left? Y plus 2, right? For the second group, what do we have in common? 3. But you need to have a sign in front of it. So beginning with positive, you just use positive 3. Then that will be what? Y plus 2, right? Then for these 2 groups, what do we have in common? Y plus 2. So we take out Y plus 2. Then what's left? We put in here. That's how we do factoring by grouping. Factoring, it ends up with what? Something multiply something. Then we want to make it the simplest term in each one inside, which would be the prime, right? Then take everything out of it, like GCF. Let's look at the next one. So 4 terms, usually we split it to 2 groups. For the first group, what's in common? 3, 4, nothing, 1, x squared and x, so you have x. Take out. So that will be 3x left. X times 3x is your 3x squared, right? Plus 4y, right? For the second group, 3x and 4y, do they have anything in common? No. So the GCF will be what? 1. And initially it's a negative sign, so you do -1. Okay? So what's left? 3x plus 4y. The idea we use negative because the inside will always be positive. So we can compare 2 of them, see if they are actually the same. So they are the same. So you take this out. So what's left? X minus 1. So that would be your final answer for this one. Okay? Factoring by grouping. Let's look at the next one. Okay, if I group first 2 and second 2, I don't have anything in common. So I end up what? 1, 3xy plus 2. Second one, I don't have anything in common. So if I take a -1 out, I have 3x plus 2y. However, in these 2 groups, they don't have anything in common. So I cannot do the further factoring. Right? Then what? We have to play around, so see what will happen. So what happens if I just change 2 of them? Switch position, because 5 plus 3 equals 3 plus 5, they are the same. So if I switch that 2, see if it works, right? If it doesn't, you might want to switch again, see you can get something from it, okay? So if I switch the second one and the fourth one, see if it will make it. So for this one, I will have y, I take out, both have y, right? So that would be 3x minus 2, right? For the second group, they don't have anything in common, so GCF is 1. But leading one is negative, so you put a negative 1 there. So divided by negative become positive, divided by positive, divided by negative become negative. Right? So in these two groups, do I have something the same? Right. Then you take out that, you have y minus 1. So that would be your factored form. That's how we do it, factoring by grouping. It's important we have to do things further with these skills. So first we learn what? Factoring, right? For the polynomial. Either 1 term, 2 terms, 3 terms, now it's 4 terms. We make it become something multiply something, okay? Either by GCF we did, or we do by what? Grouping. So how many terms we have here? 4 terms. But by looking at it, we have 4, 4, 2, 2. Number seems it has something in common. So we always take what? GCF out first. Make it simpler to deal with within the parentheses. So this, right? All have 2. So I take 2 out. So I have 2ax minus 2ab minus what? Right, bx plus b squared. Is that right? Take 2 out, right? Then for terms, try grouping. So for this one, what do we have in common? 2a. So that would be x minus b. For this group, what's in common? B. With negative to start with, so we do minus b. What's left? B. Oops, that's x minus b, right? Then for these two groups, what do we have in common? X minus b. Then you write left over here. Is this a final answer? Not really, because we have 2 originally there, so we have to carry down the 2. So that will be your final answer. Think about what we have been learning on this section. Think over so it will stick better. That would be our page 12 for your section 7.1.